I'm Cara from Connected Places Catapult, which is the UK's innovation accelerator for places and transport, for those of you who may not know. So I'm working on CREDO, which stands for the Climate Resilience Demonstrator. CREDO is a digital twin to connect different infrastructure networks, helping the overall system adapt to climate change. I'll be talking more about what CREDO is, how we implement the technology, and where we're going next. Climate change is expected to increase the frequency of extreme weather events, and we're already seeing that with the recent events like Storm Babbitt and the heat waves from this past summer. Along with the climate risks to individual assets and sites, there's growing awareness from the UK's National Infrastructure Commission, Climate Change Committee, and the Joint Committee on National Security Strategy that we lack an understanding of the cascading risk of our connected infrastructure systems. To enable greater visibility of our connected infrastructure networks, we have a vision of a federated model of connected digital twins for a complex infrastructure system. There are a lot of definitions of digital twins, but we take a broad church approach. This is really about capturing real-world systems and processes with data, then representing them in connected digital models. The real power is how simulations and scenarios can be tested in digital worlds to help decision makers and stakeholders influence the real world. We have also recognized that not all data needs to be real-time. Rather, we focus on right-time data, which depends on the use case. For those of you who aren't based in the UK, this is a quick primer on how UK critical infrastructure is organized. For electricity distribution, different organizations operate in different areas of the UK, and there's no competition between them. This is also true for water and wastewater services. For telecoms, however, there is competition in the same locations, as all the service providers that I've listed in this diagram here operate across the UK. CREDO is all about connecting across these organizations and sectors with different business models, so that's part of the challenge. For the past couple of years, Connected Places Catapult have been funding and running the CREDO project in partnership with UK Power Networks, Anglian Water, and BT Group to model their combined electricity, water, telecoms network where their infrastructure overlaps in the East Anglia region. As a first use case, we've looked at flooding, how each asset and then the entire connected system responds to the flood. CREDO is the Climate Resilience Demonstrator, a connected digital twin bringing together data from different, often siloed asset sectors to look at how they are affected by different climate scenarios, both individually and crucially as a whole connected system. Through this connected model, CREDO maps infrastructure interdependencies that previously were unknown or hidden to individual asset owners, enabling you to see when and how likely assets are to fail, and to map the cascading failures across the system that arise because of these system interdependencies. Modeling these infrastructure interdependencies enables us to know where to increase system resilience across the different asset sectors, and how to utilize investment most effectively, even if that is across sectors. So let me take you through an example. Here is a knowledge graph showcasing the connections between different sector assets, yellow being energy, purple being telecoms, and blue being water. Say there's a flood, and that causes two power assets to fail. And obviously that's not good for power. But as you can see, the initial fail of those power assets supply power to another power asset, which powers the first telecoms asset and the first water asset, which then lead to further failures to cascade across the network. So while your assets may be safe physically from the flood, the fact that they are connected to other assets means that they have failed as well. So this is what we call a cascade failure. And it showcases a real-world example of how important it is to know about those interdependencies across asset sectors, because the risk is not only siloed in your own industry. Within CREDO, you can not only see these interdependencies, but the data model will showcase how critical these assets are within that failure model. The criticality refers to how much money an asset failure will cost to the asset owner, be that fines, repairs, or lost customers. This allows you to make better decisions on where to put your investment, be that within your own asset sector or potentially across sectors, because if you're that telecoms and water company, you want to stop that power asset from failing, because that would put your own assets at risk. So hopefully you've got an idea of what CREDO is trying to solve. We can mostly split it up into these three categories. The first being the showcasing the power of bringing siloed data together. As you can see from my previous example, many asset owners are dependent on each other, but there's little transparency of these interdependencies. Bringing siloed data together enables infrastructure networks to work as one whole system, mitigating risk together and saving money in the process. Additionally, the Credo project is working on methodologies and technologies that enable data sharing across diverse systems and doing so in a secure manner. Enabling and improving strategic resilience planning takes into account everything I've just explained, including how best we utilize investment to better prepare for extreme weather scenarios. And the final, and arguably the most important point, is benefiting society and the people served by infrastructure networks every day. Making sure everyone has access to power to heat their homes in the winter, making sure everyone has clean drinking water to drink from the tap, and are able to pick up the phone and call 999 when it's necessary. Reducing the impact of climate change is only going to get harder and harder, so we need a resilient system. So I want to give you a flavor of how Credo actually works under the hood. So it all starts with data from different asset owners being combined into the Credo knowledge graph, which you can think of as a connected database that encodes not only information about the assets themselves, but about how these assets connect to each other. So from here, we feed in geographical weather data, such as the height of a flood, to understand how each asset in the network is locally impacted with our asset impact models. Then we run our system-wide models, which cascade any individual failures or impacts throughout the rest of the connected networks. And we can, as I mentioned earlier, we can then use economic models to determine the costs of the event to both operators and wider society, and decision intelligence to identify coordinated mitigation strategies, such as co-investment in flood defenses at critical sites. And the data and insights are then fed back to users, which can be visualized with map and dashboard visualizations. We worked with the economic consultancy Frontier Economics to validate the benefits and business case for Credo. They concluded that the connected resilience planning would benefit the operators through better investment and lower costs. It would also benefit customers by reducing the cost of climate change and ensuring a high quality of service. But there are also the wider benefits of improved collaboration between the public and private sectors and a better understanding of how climate change impacts infrastructure. But I think it's important to recognize that this is a journey, and we haven't solved all the problems yet. It has been 6 years since recommendations were made to improve data sharing and infrastructure. The Credo project is only in its 3rd year, and it's on its way to being a sustainable long-term project. We are now receiving innovation funding from UK regulators, and we're exploring different commercial models for the future of the platform. It's also really important to highlight how valuable collaboration between industry, startups, government, research, and academia has been on this project. Connected Places has convened everyone involved, leading on user research and data strategy for Credo. CMCL, a small media enterprise based in Cambridge, has led on digital twin engineering. The Science and Technology Facilities Council has led on data infrastructure and security. And we've also had a range of other academics and organizations contributing to this project, which you can see on the slide. As I said, this is a journey, so I wanted to spend a bit of time on how the data sharing is evolving. When we started, we had to be pragmatic. So we started by hosting all the data from the asset owners in a centralized database to keep things simple and secure. This was hosted in an isolated environment to keep the data even more secure. But we knew this approach would not be scalable, and it made it very difficult to share insights with the users. Now just animations. Then moving on to phase 2. In our secure environment, we have tested a new distributed architecture, where now each asset owner's data is stored and accessed separately. This gives asset owners more control of the data that is shared. A distributed architecture also allows Credo to scale more effectively, as it avoids the need to copy data from asset owners into an entirely new location. Yeah, so as you can see, it enables scaling. And we're using a knowledge graph technology developed by CMCL. With this technology, we're creating a common data standard that uses special data models called ontologies to bring different asset owners' data together into the same format. In doing so, we will have a common format to transform to and from, maximizing interoperability when connecting to other systems. It means that Credo can use whatever internal data structures suit its purposes while using mappings to access data in its native format held by asset owners. This opens up the possibility of different asset owners having different data formats. And this is particularly important because we all recognize that we may be in different places on the journey towards data integration and standardization. With this common data structure, Credo can provide a whole system view of infrastructure sectors and their interdependencies. But it's important to note that this is not the only view possible. Crucially, the distributed architecture supports different views of the shared data. And here it's critical to distinguish the view, which is the data that someone might pull out of the system, from the data sharing that has enabled these insights to be generated by agents analyzing the overall connected infrastructure network. So, for example, this visualization on the Anglian Water server shows assets from their network along with insights, in this case, the operational status of assets, derived from the analysis of the overall network using shared data. The insights include detailed information about the state of each asset, including information about the state of incoming and outgoing connections, even where the connections go to and from other networks. And it's a similar case for the visualization on the BT Group server and the visualization on the UK Power Network server. So this is all part of a grander vision to grow a connected digital and data ecosystem. Here, Credo would be just one use case on a distributed platform across all sectors, including infrastructure, transport, and health. So the next steps for Credo, with that goal in mind, are all about scaling. So first of all, we're working on the roadmap and looking at different commercial models to bring Credo to market in a sustainable way. We want to improve our data sharing license between data owners so we can bring in more users from across the sectors, as Credo will get more powerful the more data that it has. We're branching out into looking at extreme heat with innovation funding from water and energy regulators, showcasing how the Credo technology is extensible to different use cases. And we're looking to push into other sectors by doing the discovery work around transport use cases as well. So I'd like to talk a bit about how we approach scaling Credo. Every Credo expansion requires engaging with the same types of stakeholders. You have strategic climate resilience planners who are ultimately the target users of Credo within a given infrastructure operator. Continued engagement is necessary to ensure that Credo develops in line with their decision-making needs. Then we turn to asset data teams who help us understand whether the required data is available and can be shared. Asset strategy engineers are integral to Credo's asset failure modeling approach. Where no in-house asset failure models or past data exist, we run elicitation sessions with asset strategy engineers to build our own models of individual asset failure. I'd like to share a bit about how we've been putting this methodology into practice. So the first expansion is to the road and rail networks, for which we've conducted initial discovery. This discovery has involved researching interdependencies between the transport sector and the energy, water, and telecom sectors. Given the interdependencies between infrastructure networks, bringing any new sector into Credo also has implications for Credo's existing models, which need to be fully understood to realize the benefits of the tool. Secondly, we've outlined which transport assets might fail in the event of a flood and what consequences these failures might have for the network. We haven't yet onboarded any transport networks or authorities into Credo, but it is something we're interested in. And once we do, our discovery work would serve as a foundation for that. And I'd like to share a bit about our expansion to the extreme heat use case, for which we've been fortunate to receive innovation funding from the UK's water and energy regulators. This expansion is called Credo Plus, which has two goals related to scaling Credo. So first of all, we want to start scaling to the extreme heat use case. And this involves working with asset engineers to identify which assets are at risk of extreme heat and how they fail, which is an important first step to modeling infrastructure interdependencies. The second goal of Credo is to streamline our approach to modeling individual asset failures. Due to the lack of historic data on climate-related asset failures, we use a methodology called expert elicitation, which I briefly mentioned a few slides back. And this involves multiple rounds of face-to-face sessions with asset engineers and managers. Then academics go away to develop failure models based on these outputs, and obviously that doesn't scale very well to new asset owners, sectors, or climate events. As part of Credo Plus, we're developing a tool to streamline this process, allowing asset managers and engineers to build asset failure models themselves. By making it easier to build asset failure models, it will be easier to bring more asset owners, networks, and sectors into Credo, enabling the whole system to respond to any kind of climate event. I wanted to highlight a few considerations a user might think about for joining a Credo-style platform. The obvious one is what data you have, but what's important is to not worry too much about data quality, as the Credo platform can help with improving that. The really important things are what problems are you and your users trying to solve, and how could your data connect with other data owners so you can maximize the value of your data. Finally, I would encourage you to have a look at the Digital Twin Hub because we share a lot of information, reports, and videos. And we have some demos on this page so you can find out more. And we also have a taking action page so that different types of users across industry, research, and government can get involved. And in the off chance that any of you are attending the Energy Innovation Summit in Liverpool next Tuesday, myself and one of my colleagues will be there to answer any of your questions. So yeah, thank you for this opportunity to speak, and yeah, let me know if you have any questions.